reflection of sound. Reflection of sound. Sound is reflected from hard surfaces. Is reflected from hard surfaces. We know that light ray is reflected on smooth surfaces and it follows certain laws known as laws of reflection. Similarly, the same laws are followed by the reflection of sound. The laws of reflection of sound are same as those of laws of reflection of light. If we consider the incident sound beam and the reflected sound wave and the normal at the point of incidence, then all these three will lie in the same plane, and the angle of incidence, that is the angle between the incident wave and normal, is equal to the angle between the reflected wave and normal. Angle of incidence I is equal to angle of reflection R. I is angle of incidence, which is the angle between normal and incident ray, incident wave. R is the angle between normal and reflected wave. I is equal to R. And the three, incident wave, reflected wave, and the normal, they lie in echo. Echo. It is reflection of sound over a long distance. When we speak before a tall tower or a big wall, we notice a reflected sound, and such a reflected sound is known as echo. Echo. This echo will be noticed when we are more than 17.2 meters of distance. When we stand at a distance greater than 17.2 meters from the reflecting surface. At 22 degrees centigrade, of temperature. Why such a phenomenon exists? It is because of persistence of hearing. Persistence of hearing. What is persistence of hearing? When we hear a sound, it lasts for 0.1 seconds in our brain. We will be continuously hearing that sound for 0.1 seconds. So, meanwhile, in a time less than 0.1 seconds, if we receive another sound, this will be superimposed on the previous sound. So, we cannot distinguish these two sounds. So, if you utter the letters A with a time gap of 0.1 seconds, then you can distinguish them to be separate. But if you quickly pronounce them A like this, you cannot distinguish them because one gets superimposed on the other. Similarly, if the reflected wave comes back and falls on the ear before the original sound, it disappears in the brain, we cannot distinguish the echo. Since the speed of sound in air at 22 degrees centigrade is 344 meters per second, so the distance traveled in 0.1 seconds is 344 into 0.1, that is 34.4 meters. 34.4 meters. This is the time taken by the incident wave and the reflected wave. So, the reflecting surface should be at a distance more than 17.2 meters, so that we may hear the echo clearly. So, for a clear echo, we need to stand at a distance greater than 17.2 meters. We notice this echo near a tall building, a big wall. We will be noticing echo. Echo is nothing but reflected sound. Reflection occurs at hard surfaces. This is known as echo of sound. Reverberation. Reverberation. By standing in an empty hall or in an empty room, if you make a sound, you will continue to hear that sound with a decreasing amplitude. Such persistence of sound is known as reverberation. Reverberation. Reverberation occurs because of multiple reflections. First, it will be incident on one wall and it will be reflected to the another wall. Like this, it will be reflected several times and it comes to your ear. Such reflections produce this reverberation. When we sit in an auditorium, sometimes this reverberation is unpleasant. If reverberation is present, we cannot clearly hear the voice. We cannot clearly hear the voice if reverberation is present. So reverberation should be reduced in a hall. To reduce this reverberation, we use sound absorbing materials. We notice cushioned chairs. The material of the cushion will be selected so that it is sound absorbing. Apart from these cushions, there are certain materials used which are sound absorbents like fiberboard, rough plaster or draperies. Such substances are used for absorbing reverberation. Use of multiple reflections of sound. Basing on multiple reflections of sound, instruments like megaphones or loud hailers or horns are designed. Megaphones are loud hailers, horns, and musical instruments like trumpets and shahnais are designed to use the property of multiple reflection. Because of multiple reflections, the sound will be carried in a particular direction, in the desired direction. Because of multiple reflections in the walls of these instruments, sound will be carried into a particular direction. Stethoscope is a medical device which works on the multiple reflections of sound. The diaphragm in the stethoscope, it vibrates due to the heartbeat, and this sound is carried through the tube which is attached to this vibrator, to this diaphragm, and this sound reaches the ear of the doctor through the tube. So inside the tube, multiple reflections of sound take place. In concert halls, to direct the sound in the desired direction, we use curved surfaces. Sometimes we notice concave roof to the concert halls, to the ceilings, and sometimes curved soundboards are placed behind the stage to direct the sound in desired directions. Like this, we use several devices basing on multiple reflections of sound so as to send the sound in a desired direction.